Section 7.7, rational equations. Rational equations are equations containing rational expressions. Steps to solve. The first step is to determine the LCD of all fractions. The second step is going to be to multiply every term of the equation by the LCD. Then solve the resulting equation. And finally, check to see if any of the answers are what are called extraneous, meaning when substituted back into the original problem, they create an undefined value. So I'm going to solve letter A. I'm looking for the LCD. These are all monomials. So I look at my numbers, 6 and 3. LCD is 6. Variable is P. I'm going to multiply it. Numerator only here. Since I have an equation, I just multiply the numerator by the LCD. And after I simplify, there should no longer be fractions. So 2, so it becomes 8. Well, this is a nice simple problem. 4 equals negative P, so P equals negative 4. And if I substitute in negative 4 into the denominator, it's not going to make 0 anywhere. So that answer is fine. Letter B, I can factor. So then my LCD here, I have a 2 and an x plus 1. X plus 1, 2, and 2, x plus 1. So that's my LCD. Multiply every fraction squeeze this in here. And then I cancel out. And finish solving. Distribute. Combine like terms. Move the 7x to the other side. Move the 9 to the other side. Divide by 2. And I get x equals 6. Check 6 back into the original problem. 6 plus 1 is 7. Putting 6 in is not going to be 0, so our answer is 6. The LCD of part C is W times W minus 3. I can multiply the problem, each part kind of in my head. So I know the W is going to cancel. So I just have W minus 3. I know the W minus 3 is going to cancel. And I know that nothing is going to cancel. Since I have a quadratic, w squared, I'm going to make it equal to 0. So those two is negative 8w. So add 8w, get 5w. Add the 6. Factor. Get 2 answers. Double check. When I put in a 2, negative 2, I do not get 0. When I put in a negative 3, I do not get 0. So those answers are both good. So here's a rational function. It says the average daily cost, this is a C with a bar over it, commonly referred to as C bar, for manufacturing X bicycles. Determine the number of bicycles for which the average daily cost will be 240. So I'm putting 240 in for the cost. And then I'm solving for X. So my denominator is X. So I'm going to multiply by X. Which when I multiply this side by X, the X just cancels off, and I get X squared plus 75, X plus 5,000. This is quadratic because it's X squared, so I need to move the 240 over. And then this factors, I'm looking for 2 numbers that multiply to 5,000 and add to negative 165. I already have the answers written down, so I know what they are. But it's negative 40 and negative 125. It would take some work on a calculator to do this yourself. Then we solve each part, and we get 40 and 125. So we have 2 answers. So the question was to determine the number of bicycles for which the average daily cost will be 240. So the average daily cost is 240, 40, or 125 bikes manufactured. Another task we need to be able to do in this section is solve for the indicated variable, which means I need to rearrange the problem to get the variable that it tells me to be by itself. I'm going to start by finding the LCD and multiplying by the LCD, getting rid of the fractions. Here the LCD is 1 plus b. That's the only denominator that there is. So if I multiply by 1 plus b, it cancels out under the a. And then I'm going to distribute. And then I have to get the b by itself. So I'm going to subtract the c. And then divide by c. A minus c over c equals b. On part B, the LCD is x, y, z. So if I multiply by x, y, z everywhere, I'm going to have the x's cancel. I'm going to have the y's cancel. And then the z's cancel. And it tells me to get the z by itself. So I need to get the z's on the same side. So I'm going to subtract it. Then here's what I have to do. To separate the z from the y's and the x's, I have to factor out, because it's a GCF. Then I divide by y minus x, and I get z equals xy over y minus x.